Your results with a data-driven technology are heavily influenced by the validity of your data. You may have heard the phrase, garbage in, garbage out. What this means is that if you don't have good data, you won't get good results. Data collection suffers from bias as well. Selection bias is a systematic error involved in the acquisition of the data in a way that is not randomized or representative of the population the sample is meant to represent. The consequence of the selection bias is that the statistical analysis will not be accurate as the method of collecting samples is faulty. The impact of selection bias is that some conclusions of the data may be false. Sampling bias is a type of selection bias. It occurs when a data sample is collected in a non-random way so that some members of the sample have a different sampling probability than others. If the sampling probability is lower, this means that the group is underrepresented, and those with a higher sampling probability are overrepresented. For example, if you were surveying voters about their planned votes for an upcoming election, 1,000 voters would be a reasonable sample. But the poll would be flawed if all 1,000 voters that came were representative of one demographic. This would lead to an overrepresentation of one group and a complete lack of representation for other eligible voters. If you only poll a subset of the electorate, then the predictive ability of the poll is minimal. You can prevent sampling bias by using random sampling, where the sources are identified strictly by chance, or by stratified random sampling, where researchers create subgroups based on the population characteristics and ensure that all subgroups are represented in the sample. Another tactic is oversampling. This is the practice of selecting data so that some groups make up a larger share of the data sample than they do in the population. A time interval bias is another example of a sampling bias. It is also sometimes called a time period bias. It occurs when the researcher intentionally specifies a time range to collect data or stops data collection in a research trial after the preliminary results. Basically, it is when you artificially select a time period for data collection instead of collecting data for a wider span of time. When you limit data collection to a short period of time, it may lead to inaccurate results. For example, if you base your supply chain ordering on an average profit calculated during a 5-year span, where the demand for your product was very high and the cost of raw materials was very low, it will cause you to make inaccurate assumptions. You can counteract time interval bias by using moving averages to smooth out fluctuations, and by making sure your data spans a wide time range that will hold true under a wide range of situations. Observer bias is another way that people influence data collection. It stems from the fact that people are influenced by their own cognitive biases and aren't objective. Different observers might tend to round up or round down a measurement scale. Or, for example, observer bias can occur when you send out a satisfaction survey right after conducting a workshop. Participants might be under the influence of the personal encounter and might not want to hurt feelings with negative feedback. The consequence of observer bias is that the data will not be accurate. Observer bias can be counteracted by making sure you train your observers well and having clear rules and procedures for their participation. Misclassification is where a data point is incorrectly assigned to a different category than the one it should be in. Non-differential misclassification occurs when the likelihood of individuals being misclassified is equal across all groups in a sample. Differential misclassification is when the probability of being misclassified differs between groups in a study. Observational studies may be at greater risk, particularly those relying on self-reports and retrospective data collection. This can compromise the validity of research findings and limit their generalizability. It can lead to incomplete data and errors in data, which will impact your ability to get meaningful results. Misclassification bias can be minimized through data quality measures. This can be challenging if you are not the data owner, so you should ask questions about how the data was cleaned and prepared. You have learned how your results with a data-driven technology are heavily influenced by the validity of your data and how data can be reflective of bias in the collection process.